Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0532, indicates a problem with the AC pressure sensor circuit, specifically low voltage. This sensor is critical for regulating the air conditioning system's operation by measuring refrigerant pressure, which informs the engine control module, ECM, of AC system health. The sensor is located within the AC pressure sensor 3P connector in the engine compartment, typically near the AC evaporator box. A low voltage reading from this sensor can result in inadequate AC performance and various discrepancies in the overall HVAC system function. Comprehensive troubleshooting is required to identify the root cause of this code, which may include wiring issues, potential sensor faults, or ECM malfunctions. Follow the prescribed troubleshooting steps systematically to ensure accurate diagnosis and resolution. The error code P0532 arises when the AC pressure sensor transmits a low voltage signal, typically around 0.24 volts or less to the ECM. The AC pressure sensor's role is critical. It monitors the pressure of the refrigerant circulating through the AC system, allowing the ECM to adjust the system's operation accordingly. Located in the engine compartment, this sensor helps maintain optimal performance and efficiency in the air conditioning system. If the voltage reading drops below the specified threshold, it can lead to malfunctions such as poor cooling or complete system shutdown. Therefore, understanding this component's function and location within the vehicle is crucial for effective diagnostics and repair. Various issues may cause the DTC P0532, beginning with a faulty AC pressure sensor itself. This component can wear out or fail due to environmental conditions or manufacturing defects, leading to inaccurate voltage readings. Additionally, disconnected or damaged wiring between the AC pressure sensor and the ECM can result in the low voltage signal. Inspecting wiring integrity is essential to ensure there are no fractures or connections that could lead to voltage drops. In some cases, the ECM can also be at fault, especially if it is outdated or malfunctioning, thus failing to communicate properly with the AC pressure sensor. Correctly assessing these causes is vital for an effective resolution of the encountered DTC. The symptoms associated with DTC P0532 generally reflect deficiencies in the air conditioning system's performance. Drivers may notice poor cooling efficiency, as the AC system relies on accurate pressure readings to operate correctly. Other possible symptoms include erratic behavior of the AC system, such as fluctuating temperatures or unexplained system shutdowns. It's essential to monitor the system closely for any DTC indicators that may arise alongside P0532, as they could provide critical clues to the overarching issue within the vehicle's HVAC circuit. Documenting these symptoms is crucial in guiding the troubleshooting process. To begin troubleshooting the DTC P0532, first, start the engine and let it idle to ensure the engine is operating under normal conditions. Once the engine is running, turn on the blower switch to engage the vehicle's HVAC fan system. Subsequently, activate the AC switch to initiate the air conditioning operation. At this point, it is crucial to check the AC pressure sensor in the data list using the Honda Diagnostic System, HDS. Determine if the voltage reading is approximately 0.24 volts or less. If the reading meets this criterion, it confirms the failure condition and allows you to proceed to the next step. If the voltage is above this threshold, it may indicate an intermittent failure, necessitating further exploration for potential causes, such as loose connections or poor circuitry. Upon confirming a failure in the first step, you will proceed to determine the possible failure area of the system. Start by turning the ignition switch to the lock 0 position, ensuring all electronic systems are offline. Next, disconnect the AC pressure sensor by removing its 3P connector, which is essential to isolate the component under testing conditions. With the sensor disconnected, turn the ignition switch to on. 2. To power the system without starting the engine. At this stage, once again check the AC pressure sensor through the HDS. The same test will reveal if the voltage remains around 0.24 volts or less. A yes answer indicates you can advance to step 5 to potentially replace the AC pressure sensor. Otherwise, you should go to step 3 for further diagnostics. In this step, the focus is on identifying whether the AC pressure sensor or other components are at fault. First, measure the voltage between the designated test points, which should be between test points 1, AC pressure sensor connector number 1, black wire, and 2, AC pressure sensor connector number 3, red wire. Ensure that the ignition is in the on-I position, but that the sensor remains disconnected. The expected voltage reading should be around 5.0 volts. If the reading is accurate, it suggests that the AC pressure sensor is malfunctioning and requires replacement. On the other hand, if the voltage is out of the expected range, proceed to step 4 to examine wiring issues further, as there may be an open circuit affecting the signal to the ECM. To assess for issues in the wiring, particularly with the VCC6 line, first turn the ignition switch to the lock 0 position. This is a necessary safety precaution before performing any disconnections. Next, use the Honda Diagnostic System, HDS, to jump the SCS line, enabling the system to perform diagnostic procedures. After that, disconnect the ECM connector A49P to isolate the electronic control module from the system. Continuity testing is essential to determine if there is a break in the VCC6 wire, which connects the ECM to the AC pressure sensor. Check for continuity between 2 specific test points using the appropriate circuits. If continuity exists, this indicates that the VCC6 wire is functioning well, and any issues may lie with the ECM. If there is no continuity, repair any identified open circuit in the wiring to regain proper functionality. The final troubleshooting step focuses on the integrity of the PD sensor line. Start by ensuring the ignition switch is in the lock 0 position. Again, use the HDS to jump the SCS line to facilitate continuous diagnostic checks. Disconnect ECM connector A49P once more, and ensure that the AC pressure sensor 3P connector is also disconnected. Continuity must be checked between 2 key test points. Test point 1, located at the AC pressure sensor connector number 2, light green wire, and test point 2 connected to body ground. If continuity is present, there exists a short circuit along the PD sensor wire that must be rectified. If the wire is determined to be intact, check whether the ECM has the most updated software. If not, an update or substitution may be necessary to resolve the P0532 code and restore AC function. After all necessary repairs have been undertaken, it is essential to conduct a final verification procedure to ascertain the effectiveness of the repairs made. Begin this process by safely turning the ignition switch to the lock 0 position and ensuring that all previously disconnected connectors have been reconnected properly. Following reconnection, turn the ignition back to the on 2 position to power up the vehicle's systems. Utilize the Honda Diagnostic System, HDS, to reset the ECM, which may have stored previous error codes and settings. This reset process is crucial to allow the ECM to relearn parameters relevant to the air conditioning system and to prepare it for accurate functioning. Finally, it's imperative to perform a test by starting the engine, allowing it to idle, turning the blower and AC switches on, and checking for any recurring or new DTCs via the HDS to ensure that the issue has been resolved successfully. Preventive maintenance is critical in ensuring ongoing functionality of the AC system and preempting issues associated with DTC P0532. It is advisable to conduct regular inspections of AC system components, including the pressure sensor, so that early signs of wear or damage can be identified and addressed promptly. Additionally, maintaining proper wiring connections is vital. Regularly looking for loose terminals and ensuring the integrity of the wiring can prevent future voltage-related faults. Keeping ECM software updated is also necessary, as manufacturers regularly release updates that can enhance system performance and address known issues or bugs. Incorporating these preventive measures can significantly enhance the reliability of the AC system and help avoid expensive repairs down the line. In conclusion, the DTC P0532 indicates a crucial malfunction within the AC pressure sensor circuit, emphasizing the need for thorough diagnostics. Understanding the role of the AC pressure sensor and its significance within the air conditioning system is paramount for effective troubleshooting. Following a systematic troubleshooting approach is essential to correctly identify the root cause, be it a failed component, wiring concerns, or an ECM-related malfunction. Implementing preventative measures, such as regular inspections and updates, creates a more robust system, less prone to future failures. By adhering to good maintenance practices and understanding the diagnostic processes, vehicle owners can ensure optimal performance of their Honda Civics air conditioning system and uphold a comfortable driving experience. Please like and subscribe to the channel. See you next time.